Good afternoon, students. Welcome back to chemistry class. In last class, we studied about that periodic trends in physical properties. Today, we are going to study about periodicity in chemical properties. Periodic trends in chemical properties. Periodic trends in chemical properties. What do you mean by periodic? Periodicity means certain properties of an element repeated at regular intervals of atomic number. That is called periodicity, So in this section, we will discuss about the chemical properties such as reactivity, valence, oxidation state, etc. Also show the periodicity. And after that, also we will study about anomalous behavior of second period elements. Anomalous behavior of second period elements also in this class we will study. Okay, listen the class carefully, take notes. This is very useful to you. Okay, and first upon, what do you mean by valence? What do you mean by valence or oxidation state? What do you mean by valence or oxidation state? The valence means the combining capacity of an atom with other atom. Valence means combining capacity. Okay, let me explain with Octet Rule. What do you mean by Octet Rule? Octet Rule means octet means 8. Okay, electrons in 8. So all elements, about Octet Rule, all elements are trying to acquire noble gas configuration, that is 8 electrons in their outermost shell. Okay, all elements are trying to get noble gas electronic configuration, that is 8 electrons in their outermost shell. This is called Octet Rule. Another one, configuration, this is duet configuration. Duet configuration means certain elements, that is hydrogen, helium. Okay, helium is the one of the stable electronic configuration. There is duet configuration. Okay, a doublet configuration. There only 2 electrons in their outermost orbit. So also helium also stable. That is a doublet configuration or duet configuration. Understood? So if they have the electrons which are less than 8, that they have 3 choices. Either they lose electrons and acquire octet configuration, acquire the previous noble gas configuration, okay, or either gain electrons, they acquire the next noble gas configuration. And another one option, they have combined with each other and they share the certain pairs of electrons in order to acquire the octet configuration. Okay, for example, I explain. For example, sodium atom, sodium atomic number 11, electronic configuration 2, 8, 1. Okay, so the outermost electron, how much electrons are? Have only 1 electron. So sodium atom try to lose this 1 electron to get the stable previous noble gas configuration. Okay, what is the previous noble gas, nearest previous noble gas configuration for the sodium atom? That is neon atomic number 10. Okay, so sodium atom try to lose 1 electron from their outermost orbit to form the stable neon configuration. Okay, another one example, I am telling the chlorine. Chlorine atomic number 17. Atomic number 17 means what is the electronic configuration? First shell 2 electron, second shell 8 electron, outermost shell 7 electron. So chlorine atom try to gain 1 electron from any other atoms to get the stable next noble gas configuration. Which one is the next noble gas configuration for the chlorine atom? That is argon. Argon 18, chlorine 17. Oxygen atomic number 8. Okay, try to get to the extra atomic number 8 means outermost 2 comma 6. Okay, outermost orbit having 6 electrons. So try to get 2 electron to get the next noble gas electronic configuration. What is the next noble gas configuration for the oxygen atom? That is neon 10 atomic number. Okay, so these are about the octet rule. So here, what do you mean by valence? Valence means the combining capacity of an atom with other atom by either losing or gaining or sharing its pair of electrons with other atoms. Okay, so valence or oxidation state, it is equal to the, usually the valence means it is equal to the total number of electrons in the valence shell. Valence means the total number of electrons in the valence shell are equal to 8 minus the number of valence electron. 8 minus the number of valence electron. Okay. Okay, here valence means this is equal to the total number of electrons in the valence shell or equal to the 8 minus the number of valence electron. Okay, two are the same. Two concepts are same about valence. Okay, valence means the outermost electron. Valence electron we called as the valence. Otherwise, 8 minus the number of valence electron. 8 minus the number of valence electron. Okay, we can take two concepts we can take as the valence. Okay, for example, I am telling again sodium atom we can take as the example for the valence or oxidation state here. So what is the atomic number for sodium? 11. What is the electronic configuration? 2, 8. Sorry, 2, 8, 1. Okay, so what is the valence of the sodium atom? 1. Because the valence means number of electrons in outermost orbit. Here only 1 electrons are having in outermost orbit. So what is the valence of sodium atom? Only 1. Okay, otherwise what is valence or oxidation state? What do you mean by oxidation state? Oxidation state are typically represented by integers which can be positive or negative. Okay, here the sodium atom, positive means when an atom lost an electron to form metal positive ion, that is called a positive. Okay, here sodium, lithium, these all elements can lose electrons and to form positive ions. Okay, here sodium atom can lose 1 electron and to form sodium ion Na plus. So here what is the oxidation state? Plus 1. Okay, so plus or minus. Okay, the value is oxidation state means the valence electron. Valence means the number of electrons in the valence shell or 8 minus the number of valence electron. That is called valence. Okay, so here we are taking what is the valence of sodium? 1. So what is the oxidation state means? Plus 1. Understood? And another one example, I am taking oxygen. What is the atomic number for oxygen? 8. Electronic configuration 2, 6. 2, 6 we know it is not stable now because the outermost orbit only 6 electrons are having. Okay, so it needs 2 electrons to get the stable electronic configuration. Okay, so oxygen atom gain 2 electrons with any other atom to form to get the stable configuration and to form the bonds and to form molecules. Okay, understood? So here what is the valence of oxygen? What is the valence of oxygen? For oxygen, what do you mean by valence? Valence means combining capacity, and what is the valence? Means it is equal to the number of valence electron or equal to 8 minus the number of valence electron. So here number of valence electron 6. Okay, so we can take 6 as valence. Otherwise, we can take 8 minus 6. Okay, 8 minus the number of valence electron. Number of valence electron 6 means 8 minus 6 is equal to 2. Okay, so we can take either we can take as the 6 or either we can take as the 2 as valence. But the priority given to 2 for the oxygen atom, because the combining capacity of the oxygen atom it need 2 electron to get the stable configuration. So this is the lesser value, small value 2. So for all the reactions we can consider 2 as the oxidation state for oxygen atom. Okay, valence for the oxygen atom. So what is the oxidation state here? Oxidation state positive or negative? Negative, because it accepts 2 electrons with any other atom. Okay, so oxygen atom need 2 electron. It accept, it gain 2 electron from any other atom. So oxidation state, what is the valence of the oxygen means 2. What is the oxidation state? Plus 2. Understood? Sorry, minus 2. Okay, because of the gain. When electron lost electrons, it becomes positive ion. When an electron gain electrons, it becomes anion. Okay, when an atom lost electron, it becomes cation. When an atom gain electrons, it becomes anion. Understood? So these are about the valence or oxidation state. Now we are going to study about periodicity of valence or oxidation state. How the oxidation state vary along the periods, and how the oxidation state or valence vary along the groups. Okay, first upon how the valence vary along the groups. Okay, so here the group means how many groups are there in periodic table? There are 18 groups are there. Okay, what are the these 18 groups? We can divide into 4 blocks. What are the 4 blocks? S block, P block, D block and F block we know. Okay, so the S block we call this the alkali metal and alkaline earth metal. P block we call this the representative elements. S block element are very reactive elements. Okay, S block and P block, 2 block elements are very reactive, but D block and F block elements are less reactive. Okay, here we are taking how the valence or oxidation state vary along the groups. Here I am taking alkali metal, group number 1. Group number 1, lithium, sodium, potassium, rubidium, cesium, francium. Okay, this is the group number 1. How many valence electron you know? All the elements in the same group shows the same valence electron, you know. Okay, except the D block and F block elements, the S block and P block elements, all the elements have the same valence in the outermost orbit. Okay, so lithium atom, you know, lithium, sodium, potassium, cesium, francium, all the elements have the same valence electron. Okay, lithium atomic number 3, so 2,1, sodium atomic number 11, 2,8,1, and the potassium 19, 2,8, 8,1, so and so on. Okay, so all the elements in the same groups have the same valence electron or valence. Okay, so here we know sodium, potassium, lithium, sodium, potassium, rubidium, cesium, francium. These all elements have the same valence, that is 1. Same oxidation state, that is plus 1. Okay, so here Another one group I am taking here, group number 15. Group number 15 elements are nitrogen, phosphorus, arsenic, antimony and bismuth. Okay, so these elements, nitrogen, phosphorus, arsenic, antimony and bismuth. For these elements, how many number of electrons in their valence shell? For these, this is the p block element. Group 15 have the p block elements. Okay, p block elements. So these p block elements have the same valence electron, that is 5. Okay, all the elements having the same valence electron, that is 5. So what is the valence for these all elements? What is the valence? Here, you know what do you mean by valence? Valence is equal to the number of electrons in the valence shell are equal to the 8 minus the number of valence electron. Okay, the valence means valence is equal to a number of electrons in the valence shell or equal to 8 minus the number of valence electron. Understood? Here you know what is the valence for the nitrogen. How many number of valence electrons are having here? 5. What is the valence? We can take 5 as the valence. Otherwise, 8 minus 5 is equal to 3. Okay. So what is the valence of nitrogen means 3 or 5. Any one we can take it as the valence for the nitrogen. Okay, but priority given to 3. Priority given to 3 for the nitrogen atom because it is the low value, and other reason how many electrons in the nitrogen atom is willing to it need to be filled. How many electrons in nitrogen atom need to be filled in order to satisfy the rule of octet? How many electrons need? 3 electrons need. Okay, so on because of this nitrogen atom, what is the valence priority given to 3 as the valence for the nitrogen atom? Okay, we can take 3 or 5. Any one value we can take as the oxidation state, but priority given to 3 for the nitrogen atom. Okay, this is same for all the elements in this groups. Okay, group 15, all the elements, what is the valence? 3, 5, nitrogen 3 or 5, phosphorus 3 or 5, arsenic 3 or 5, antimony 3 or 5, bismuth 3 or 5. Because what is the valence means? Valence is equal to the number of electrons in valence shell or 8 minus the number of valence electron. Okay, but priority given to 3 for the valence of nitrogen atom. Okay, and next we are going to study about how the valence is vary along the period. How the valence vary along the periods. Okay, now I have taken the first period elements. Second period element. I am taking now second period element. What are the second period elements? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. This is the second period element. Number of electrons in valence shell for lithium 1, because atomic number, what is the atomic number for lithium? 3. So 2, 3, 1, valence electron 1. Beryllium 2, boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7, neon 8. Because in period the atoms are arranged in the increasing order of their atomic number. Okay, so the first start with lithium 3 and beryllium 4 atomic number, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 7, fluorine 9 and neon 10. This is the atomic number for these second group elements, second period elements. Okay, so here what is the valence? Valence means combining capacity. Okay, so valence definition, it is equal to the number of electrons in the valence shell or equal to the 8 minus the number of electrons in valence shell. Okay, so here valence, what is the valence of lithium? How many number of electrons are present in lithium atom? Only 1. Okay, so we can take as the 1 for the valence for the lithium atom. Okay, and then boron 3, so we can take as the boron as the valence. For carbon 4, so we can take 4 as the valence of carbon. Okay, 4 as the valence of carbon. So lithium atom can donate 1 electron to any other atom. So what is the combining capacity of lithium? 1. Beryllium atom can donate 2 electron lost 2 electron with any other atom. Boron give 3 electron to any other atom. Carbon atom give share 4 electron to any other atom. Okay, so the combining capacity of these 4 elements are on the basis of their valence electron. So valence of these 4 electron same as the valence electron. Okay, but here nitrogen, oxygen, fluorine and neon. Nitrogen, how many number of valence electron? 5. So what is the nitrogen? It cannot lose 5 electrons. Okay, because it need high energy to remove these to remove 5 electron with any other atoms. Okay, so nitrogen atom gain. Nitrogen atom not lose electrons because it is 5. It is higher than 4, more than 4. Okay, if we remove the 5 electrons in the outermost shell of the nitrogen atom, we should give more energy to remove the electrons. Okay, so it cannot, we cannot remove the 5 electrons in the valence shell of the nitrogen atom. So always a nitrogen atom accept 3 electrons. Okay, so 8,5 means 3 electron. So combining capacity of nitrogen atom means it gain 3 electron with any other atom to form molecule. Okay, for example ammonia, formation of ammonia, nitrogen with 3 hydrogen atom. 3 hydrogen atom give share each 3 electrons to the nitrogen atom. Okay, so and another one oxygen. Oxygen, how many valence electron? 6 number of valence electron having. What is the valence of oxygen? What is the combining capacity? Oxygen atom cannot lose 6 electron with any other atom. So oxygen atom gain 2 electron to get the stable octet configuration. Okay, understand? So what is the valence of oxygen? 6, 2. So 8, 6 is equal to 2. Okay, so 6, 2. So more preference given to 2 as the valence of oxygen. Okay, and fluorine, what is the valence electron? 7 valence electron. So it is more electronegative atom. Fluorine is the one of the very high electronegative atom. So it always attracts the electrons with any other atom. So how many electrons need to get stable configuration for the fluorine atom? 1 electron, 1 more electron. Okay, so fluorine atom get 1 more electron with any other atom. So 8 minus 7 is equal to 1. So combining capacity of fluorine means 1 electron to gain 1 electron with any other atom. Okay, so valence of fluorine means 7 or 1, but not consider 7 as the valence of fluorine atom. We consider 1 as the valence of fluorine atom. Okay, so what is the oxidation state for fluorine? -1, because it gain 1 electron to form anion. Fluorine minus, so -1. Understood? So neon, what about the neon? Neon atomic number 10. What is the valence electron? 8. Okay, valence electron 8. What is the valence of neon? 8. Okay, so what do you mean by valence? Valence is equal to the number of electrons in the valence shell. Okay, this is the periodicity of valence or oxidation state in along the periods and along the groups. Okay, here some elements have variable valence. Okay, for example, most of the elements in group 15 have the 5 valence electron. It shows 2 valences. What are the 2 valences? 3 and 5. Okay, and group 16 element, that is oxygen family. We know oxygen family. In the oxygen family, all the elements, most of the elements in oxygen group 16 elements having the 2 valences. What are the 2 valences? 6, 2, 6 and 2. And 17th group elements, that is halogen family, all the elements in group 17 elements having the shows maximum 2 valences. What are the 2 valences? 7 and 1. Okay, these are about the similarly the transition metals also, the transition metal D block elements and F block elements, the transition elements and inner transition metals shows the variable oxidation state. Okay, that's all about the valence or oxidation state. Then we are going to study about anomalous behavior properties. Anomalous properties of second period elements. Anomalous properties of second period element. Very, very important. Listen carefully. Anomalous behavior properties of second period elements. Here, what do you mean by anomalous? Anomalous means deviation. Anomalous properties means deviation of the properties of an element from its usual or normal behavior. Okay, deviation of the properties of an element from its usual or normal properties, that is called anomalous properties. Okay, anomalous properties. Now we are going to study about the anomalous properties of second period elements. Okay, as we know, the elements of the same group shows similar physical and chemical properties. Already we studied about that. Elements of the same group shows the similar physical and chemical properties because all the elements in the same group having the same valence or valence electrons. Okay, so all the elements in the same groups shows the similar chemical and physical properties. However, the first element of each group differs from other members of the group in certain properties. Okay, the first members of the each group. How many groups are there in a periodic table? There are, we know 18 groups are there. So first member of the each group. Okay, first members of the each group shows the different properties. Okay, than other elements of the same group. Okay, for example, I am taking lithium. Lithium first group elements where begins from lithium to cesium. We know lithium, sodium, potassium, rubidium, cesium, first group elements. For the first group elements, we know all the first group elements have how many number of valence electron? Only one number of valence electron, only one valence we know. So here the lithium shows, we know the first group elements, the sodium, potassium, rubidium, cesium, these all elements having the one valence. So what is the combining capacity of first group elements? It can lose its one electron. Okay, it can lose its one electron to any other atom to get the stable configuration. The sodium atom, let us consider sodium atom, atomic number 11, electronic configuration, first shell 2 electron, second shell 8 electron, last shell 1 electron. So sodium atom always try to lose this one electron to get the stable configuration. Okay, so the when combining the sodium with other elements, what is the bond formed there? Ionic bond formed. What do you mean by ionic bond? The bond is formed between the two atoms by the complete transfer of electrons, complete transfer of valence electron from one atom to other atom. Already we studied about that with example. Okay, but the lithium in the first group, first element, the element of the first group. Okay, so the lithium only shows the covalent character. lithium atom only shows the covalent character. How? Because the lithium atom atomic number 3, you know, what is the electronic configuration? First shell 2 electrons, second shell 1 electron. Okay, so when lithium, what is the how the lithium combines with the other elements, lithium hydride. Okay, for example, lithium hydride, lithium combines with the hydrogen atomic number 1. So what is the valence electron? Only 1. Lithium only 1 valence electron. Okay, so a lithium atom, it cannot lose this 1 electron, because hydrogen atom also only 1 electron. Okay, so this lithium atom share this 1 electron to this hydrogen atom. Like that, this hydrogen atom share this 1 electron to this lithium atom. So by sharing these 2 electrons, one of the bond is formed. That bond is called a covalent bond. Okay, so a lithium atom only shows the covalent character. Understood? But all the other elements in the first group shows the ionic character. Like that, the beryllium, it is the second group elements. Beryllium, magnesium, calcium, strontium, barium, these are the second group elements. Okay, here beryllium, the first element in the second group. The beryllium shows the covalent character, but all other elements in the second group shows the ionic character. Understood? This is the one of the anomalous behavior of elements. And another one, anomalous behavior, very very important, that is the elements of the second period have only 4 orbitals in the valence shell and have a maximum covalence of 4. Okay, covalence. What do you mean by covalence? Covalence means, what do you mean by covalence? Covalence means the ability of elements with share this electron with other element. That is called covalence. Okay, ability of elements to share this electron with other elements, that is called covalence. Okay, covalence, maximum number of electrons can involved in the chemical bonding, that is called covalence. Okay, maximum number of atoms can formed with a compound, that is called covalence. Okay, for the second period element, comparing here second and third period element. Okay, the second period element have only 4 orbitals. We know what are the second period element. Lithium to neon, lithium first, beryllium second element, boron third, carbon fourth, nitrogen fifth, oxygen sixth, and fluorine seventh, and neon 8th element. Okay, understood? So this second period element have only 4 orbitals. Okay, for lithium, how much orbital? Lithium atomic number 3, how much orbitals are there? 1s2 and 2s1. 1s2 and 2s1. For beryllium, 1s2 and 2s2, and boron 1s2 and 2s2 and 2p1. Carbon 1s2 2s2 2p4, 2p2. Nitrogen 1s2 2s2 2p3. Oxygen 1s2 2s2 2p4. This is the, so this we are considering the second period element. All the elements shows the only 4 covalence, only 4. There is 2s and 2p. What is the outer shell electrons, outer shell orbitals? How much outer shell orbitals are there? Only 2s and 2p orbit. Outer shell, how much? This is the k shell, 1s2 orbital, this is the k shell. And what is the L shell? 2s and 2p. L shell, how much orbitals are there in L shell? S and p. Okay, here 2s and 2p orbitals are there in second period element. Okay, boron and carbon also. Okay, so the second period element shows the only 4 orbitals, have only 4 orbitals. So in the maximum capacity of sharing electrons in orbitals, only 4. Okay, there is covalence only 4. For example, I am taking the boron. It is the third element in the second period. What is the atomic number for boron? 5. What is the electronic configuration? 1s2, 2s2 and 2p4. 1s2, 2s2 and 2p1. What is the orbital diagram? How will you draw the orbital diagram? 1s2 and 2s2 and 2px, 2py, 2pz orbital. Okay, here 1s2, how much? 2 electron, and 2px 1 electron. This is the totally 1 2 3 4 5 electrons in boron atom. Okay, here only 4 orbitals. The outer shell orbitals 2s and 2p orbital. Okay, 2s and 2p orbital. This is the outer shell orbitals. Okay, when the fluorine atom maximum, how we can identify the maximum capability of forming the compounds with other element. Okay, so here this is in ground state, but if it goes to the excited state, this 1 electron goes to the 2py orbital. This 1 electron from the 2s orbital goes to the 2py orbital. Okay, 2py orbital. So the 1s2, 2 electron, 2s 1 electron goes to the 2py orbital. Okay, here remaining only 1 orbital are in free state. Only 1 free orbital there. So boron, what is the valence of boron? We know 3, because it lost this 3 electron with any other element. Okay, here fluorine, when boron maximum combining capacity maximum 3 valence, so the boron can lose 3 electrons only. Okay, so this boron gives these 3 electron to each fluorine atom, 3 fluorine atom. Okay, boron atom lost 3 electron to 3 fluorine atoms. Okay, and another 1 orbital are in free in the boron atom. So another 1 fluoride ion, already extra 1 electron having the fluoride anion. This 1 anion, it will goes to this, it will occupy this free orbital. Okay, so maximum capacity of covalence is 4 here. Maximum covalence 4 elements only combines with this 2p. All the other elements in second period elements are having maximum covalence of 4. Okay, 4 elements only, 4 any other atoms only combine with this second period element. Okay, whereas the other members of the other period, third period, fourth period, fifth period elements shows higher valences. For example, another 1 example here, boron combines with the 4 fluorine atom to form BF4 minus, because this one the boron atom only 1 electron here. Only 1 electron free state. Okay, only 1 orbital free state. So this 1 electron, extra 1 electron added to this free orbital. So BF4 minus. Okay, and another period elements shows higher valences than the second period element. For example, aluminium. I am taking aluminium, atomic number 13. What is the electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p1. Okay, so orbital diagram: 1s2, 2s2, 2px, 2py, 2pz, and 3s2, 3p1, and this is the first shell, K shell. This is the second shell, L shell. This is the third shell. Third shell, how many orbitals are there? 3 orbitals. What are the 3 orbitals? 3s, 3p, and 3d orbitals also there in third shell. Okay, how many free orbitals are there? 1, 2, 3, 4, 5, 6, 7. Okay, for 7 free orbitals are there, but it is in ground state. But it goes to the, when it goes to the excited state, one electron from the 3s orbital goes to this 3py orbital. This 3px, 3py, 3pz. D orbital, what is the name of D orbital? 3dx, y, 3dyz, 3dxz, 3dx square minus y square, 3dz square. This is the orbital name. Here, it is in excited state. One electron from the 3s orbital goes to the 3py orbital. Okay, 3py orbital. So remaining, how many orbitals are remaining? Free state 1, 2, 3, 4, 5, 6 orbitals are there. Okay, understood. But here the aluminium atom only combined with the 6 fluorine atom only, because these the 3 electrons, aluminium, outermost electron, 3 electron. What is the valence of aluminium? 3. So it can lose 3 electrons to the other element. So this 3 electron fluorine atom gain. Okay, and the remaining orbitals, free orbitals, so 3 fluorine atom can be accommodated in remaining 3 free orbitals. Okay, fluoride ions, fluoride anion can be accommodated in 3 orbitals. Okay, what are the 3 orbitals? 3pz orbital, 3dxy and 3dxyz orbital. Okay, 3dxy, 3dyz orbital, remaining fluoride minus ion occupied. Understood? Now, what is the compound forming here? Aluminium hexafluoride 3 minus. Because why 3 minus? The 3 minus fluoride ion occupy these 3 free orbitals. Okay, understood? So these are about the anomalous properties of the second period element. Okay, what are the anomalous properties? The lithium and beryllium form more covalent compounds, unlike the alkali and alkaline earth metal form the ionic compound. Okay, second example, the elements of the second period have only 4 orbitals. There is 2s and 2p in the valence shell and have a maximum covalence of 4, whereas the other members of the subsequent period have more orbitals in their valence shell and shows higher valences. For example, boron forms boron tetrafluoride minus, and aluminium forms aluminium hexafluoride 3 minus ions. Okay, understood? Okay, students, then we are going to study about diagonal relationship. Diagonal relationship. What do you mean by diagonal relationship? On moving diagonally across the periodic table, the second and third period elements show certain similarities. Okay, when you are moving diagonally means, what do you mean by diagonally? Diagonally means this, like, okay, lithium, this is the period. Okay, lithium, beryllium, boron, carbon. This is the second period element. Sodium, magnesium, aluminum, silicon. This is the third period element. Okay, so here when similarities of this element, already we studied about that the first element of the first and second period, second group elements, first elements, this is the covalent character. All the other elements shows the ionic character, we know. Okay, so like that here certain properties on moving diagonally across the periodic table, the second and third period elements show certain properties. Okay, so certain similarities properties. Okay, lithium and magnesium, magnesium shows the similar certain properties. Okay, certain similarities only. Beryllium and aluminum shows the similar properties, and boron and silicon shows the similar properties. Okay, so the similarity in the properties existing between the diagonally placed elements is called a diagonal relationship. Okay, what do you mean by diagonal relationship? The similarity in properties existing between the diagonally placed elements. Diagonally placed element, this is the diagonally. Okay, similarity in properties existing between the diagonally placed elements is called the diagonal relationship. Understood? These are about the diagonal relationship. Okay, I think all of you understood. Okay, students, today's your assignment. Three questions I will give today. What are the three questions? What is first question? What is valence or oxidation state? Second question, mention any two anomalous properties of second period elements. Third question, what do you mean by diagonal relationship? Three questions you should study and write and send me through my WhatsApp number. If you have having book, take your book now. Take page number 88. What is the first question? Valence or oxidation state. The valence of an atom is the combining capacity related to hydrogen atom. And it is usually to the total number of electrons in the valence shell are equal to the 8 minus the number of valence electrons. It is more convenient to use the oxidation state in the place of valence. Up to here you mark first. The third paragraph fully you mark. Okay, and the second question, what is the second question? Mention any two anomalous properties of second period elements. This is the last paragraph, page number 89. Anomalous properties of second period element. The third line onwards you have to mark. Lithium and beryllium form more covalent compounds, unlike the alkali and alkali earth metals, which predominantly form ionic compounds. The elements in the second period have only 4 orbitals in the valence shell, 2s and 2p, and they have a maximum covalence of 4, whereas the other members of the subsequent periods have more orbitals in their valence shell and shows higher valences. For example, boron forms boron tetrafluoride minus, and aluminium forms aluminium hexafluoride 3 minus. Up to here you mark. What is the third question? Page number 90. What do you mean by diagonal relationship? The second paragraph, the similarity in properties existing between the diagonally placed elements is called a diagonal relationship, and this diagram also you should mark. Okay, thank you students.